Hi everybody, my name's Jakub and I will show you now how to solve the third example from today's problem set. Let's read what it is about. Nisha has 8 coins. She knows that at least one of the coins is real, but she doesn't know which one. All the real coins weigh the same. If any of her coins is counterfeit, it is lighter and all the counterfeit coins weigh the same, but different than real coins. She has balanced scales and can weigh coins against each other. Show that she can weigh her coins 3 times and find out if there are any counterfeit coins among the 8 that she has. So we don't have to find out which ones are counterfeit. We don't have to find out how many counterfeit coins are there. We only have to find out if there are any. Okay? And what that means in practice is that we just need to find out if all the coins weigh the same or if they have 2 different weights. Because if they have 2 different weights, then some of them are counterfeit. If they all weigh the same, then all of them are real. Okay. Right. So we have 8 coins to begin with. There are coins from Starland or something, and we have some balance scales. Right. The first observation we're going to make is the same observation we made last time, like last 2 times. It does not make sense to put different numbers of coins on each side. Why? Because let's say we put more coins on this side, it goes down. More coins are heavier than fewer coins. We have learned absolutely nothing. Don't do this, okay? The second observation, which is specific to this problem, is that we need to measure all the coins at some point, right? We need to measure all 8 of them. Somehow each of them has to end up on the scales at least once, because let's say we leave one out and we conclude that all the other 7 weigh the same, right? What we don't know is the one we didn't measure is lighter or heavier. So we can never tell if the 7 that we have that weigh the same are all real or fake, or if the 8th one is fake or real. We cannot tell because we left one out, right? So we have to put them all on the scales at some point. So what we start with is we just split them evenly. So we put 4 on one side, okay, and 4 on the other side. Okay, and then obviously there are 2 things that can happen effectively. One thing is that the coins do not balance out, right? If one of those is counterfeit, or maybe 2 of them are counterfeit, right? 2 of them are counterfeit, then the scales do not balance, like this will go down. And the funny thing about this problem is that if the scales don't balance at any point, that means there are some counterfeit coins. That means that the coins weigh different amounts, because we always put the same numbers of coins on each scale. So the only possibility in which they don't balance is because the coins that we put there have different weights, right? So that is the end, right? In this case, that is the end. We know some of the coins are counterfeit, right? But what if the scales balance? The scales balance after the first step. That means that we have the same number of counterfeit coins of both scales, right? The scales can still balance if there are counterfeit coins. We just require there to be the same number of counterfeit coins on the right and on the left. So in this case, let's mark, there will be 2 here and 2 here, right? So what we do in this situation is we look at one scale, right? It either has some counterfeit coins or it doesn't. If there are counterfeit coins, then there will be some counterfeit coins on each scale. So it doesn't matter which one we choose. If there are no counterfeit coins, there are no counterfeit coins. If there are counterfeit coins, there are the same number of both scales. So whichever scale we choose, we'll always find some counterfeit coins there. And we split those into 2 scales. So one stays here and the other goes to the other one. Right? Now we have 2 on each side, and they come from the same side, right? So if there are any counterfeit coins among the 8, there will be some counterfeit coins here. Again, 2 things can happen. If they don't balance, right? If they don't balance, then we have the same situation. If they don't balance, that means that some of them are counterfeit. So this is the end. We don't have to do anything else. We just did 2 measurements, and we found out some of the coins are counterfeit. We don't have to do anything else, right? But if they balance again, this doesn't mean that all the coins are real. The logic here only works in one direction. if all the coins are real, the scales will always balance. But if the scales balance at this point in the solution, doesn't mean that all the coins are real. It might mean that there's one counterfeit coin on one side and another counterfeit coin on this side, right? It is possible. So what we have to do is we have to do the same thing again. We pick one side and we split it. We put one coin here and one coin stays here. The rest, the other two we toss. We toss them somewhere else, right? They're gone, right? We don't have to measure them anymore, right? Now we have the situation, we have one coin on each side, and again, there are two possibilities. Might be that this coin is counterfeit, it is lighter. And again, what that means is that the scales do not balance at this point. That means some of the coins are counterfeit, and this is the end. We know that there are counterfeit coins here among the 8 coins. We solved it, we know, we found out, right? But it might also mean that they balance for the third time. And if they balance for the third time, it actually means that all the coins are real. This time it doesn't mean that, right? Because the only situation in which the scales balance is that the number of counterfeit coins on both sides is the same. But it might be 0, right? If both of those were counterfeit, that means that all 4 in the previous step had to be counterfeit, and all 8 at the beginning had to be counterfeit. But we know that in the problem it says that at least one coin is real, right? At least one coin is real, so they can't be all counterfeit, right? And because we are choosing a half, and in each half there would always have been some counterfeit coins. Well, then if we split them, at least half the counterfeit coins will sort of go to the next step. So if there were any counterfeit coins at the beginning, at the end the scales would not balance, at least once, right? So following those steps, in 3 steps, or 1 or 2, maybe we just need 1 step, maybe we need 2, maybe we need all 3, but in 3 steps you can always find out if there are any counterfeit coins or if all the coins are real, right? I hope that was helpful, and see you next time.